Hey guys, welcome to another tutorial video of mine using Maya. Today I'm going to show you how to make a shield like is in another one of the videos I uploaded. Let me just show you that. So to make that kind of effect, what we need is first we need to download, if you haven't already, the Substance Bonus Tools by Algorithmic. And let me just bring up their page. I just search for Substance Bonus Tools on Google, and you can see it right here. It's this first line. And you can just basically hit download it now. It comes with a bunch of instructions. To show you what they do, let me first create a few objects. Let's create a polygon plane. Just going to use this as a ground plane. Stretch it out. Let's turn on shader mode. And create a sphere. Scale up the sphere. This is the object that we're going to be using to make the shield. So I'll use this as the demo object for the tools. So to add the tools to the tools material to this sphere, what we need to do is first bring up the hypershade. So open up the hypershade, and what you want to do is create a node called Substance. So use this search bar up here, and make sure you click Substance and not Substance Output. So what you'll see is that it's created this Substance node, and it looks for a Substance file. So the Substance files are also made by Algorithmic, but there's a plugin that supports them. So if you don't know how to get that plugin working, just look at the bonus tools documentation. I believe it talks about it. And to access the bonus tools, what you need to do is go to wherever you installed them. Oops, wrong version of Maya. And the directory Substance. And the one I'm going to use is the stylized, I believe it's Electric Liquid. Open that up. Yep, so that's the one I want to use. And basically, for it to create a shader, all we have to do is click this button here, and it'll create its own network and everything. So let's just drag this on and see what it looks like. At first nothing shows up, and to fix that all we need to do is turn on high quality rendering. So when that's on, we can now see this material appearing here, and it looks pretty cool. So this isn't going to be a tutorial on how to create these materials. Algorithmic already did. So let's look at this node, the Substance 1 node, and let's click Substance Parameters. Change animation to 1. And now watch what happens. So I'm just going to resize this so it's a little faster. It's an animated texture. They have produced animated procedural textures that you can use, which is cool. So, as you can see, that's what it does. There's a bunch of these different parameters here. Changing the speed will make it go faster. That's what I did in my example video. So yeah. Anyway, let's get to work. Put this back up at 512. So what you can see is there's a bunch of different features here. Most of them are self-explanatory, such as hue shift, saturation, luminosity, contrast, and liquid color, and speed. If you want it to be animated, you have to set this animation value from 0 to 1. Make sure you do that if you want it to be animated. Anyway, so as you saw with the shield, it was transparent in basically these gray areas and opaque in these white areas, and it also had a glow. So that's what I'm going to be teaching you guys today, and hopefully it doesn't take too long. Alright, so let's get started. Basically what we want to do is we want to play around with ways to use this texture here and generate maps that can work for transparency and some other things. So, first thing we need to do is let's create a new shader. Let's create another Lambert. Sign there. It appears in our work area here. Cool. So, we want this object to be transparent where the texture was dull, and I'm just going to apply the material down to this ground plane, and opaque where it's white. Now the first thing you might think is to apply the out color of this to transparency. Let's do that and see what happens. So you can see you get this weird looking semi-transparent wrong look. And if you render at, it looks pretty gross. That's definitely not what we want. Before I continue, I'm just actually going to switch my view to have a much more natural view for this. So just switch to Hypershade / render / perspective, because we're going to be using all three of those, and I think it's a better arrangement. Cool. So anyway, so that clearly didn't work. If you can't find where your material went, just drag it into the work area and click it, and then hit Graph Input and Output Connections. That'll show you pretty much everything you need. Alright, so obviously connecting it straight to transparency didn't work. So let's break that connection, because that's no good. So what should we do? Maybe if we were to invert the transparency map, we would get the proper transparency. So how do we do that? Well, Maya has a useful utility node called remap color. And that does exactly what you think it does. It'll remap the color. So you create this remap color node, and what you see is, when you select it, all these slider or graphs here. And basically, first thing you want to do is take this emissive color, or emissive substance 1 node. This is outputted from the substance node. So take this one, and I'll explain why to do that later, and plug it into the color of the remap color. So that's basically going to be the input for the remap color, and then the output is going to be the remapped color. So to see what it does, let's take our ground plane and assign it the output of this remap color. So we need to break this connection and put this in for, let's just put it in for color. So that's what the color of it looks like. By default, the substance material is mapped to incandescence, I believe. But I just mapped to color in this case. Anyway, to see what it does, let's just play around with some of these. Let's do blue. As you can see, it changes the basically color level. And I'm not going to explain what it does there. Basically just changes the color's intensity as a function of input channel magnitude. So don't worry about that. And delete that. So what we want to do is invert it. And to invert it using this node, it's actually pretty simple. All you have to do is drag each one of these graphs to be opposite of what it actually is. So do that. And what you'll see is that now we have an inverted image. So what happens if we apply this to the transparency channel? Well, cool, that seems to have worked. The regions that we wanted opaque are indeed opaque. The regions we wanted semi-transparent are semi-transparent. The colors look a little bit off, so we definitely need to add a color to this Lambert 2 material that we've created that's not the default gray. So one thing we can do is just plug this emissive substance in for, let's plug it in for incandescence, because that's what it default plugs into, and that's brighter. Oh, whoops, wrong material. Plug it into the Lambert 2 for incandescence. Now what you'll see is this gets very bright. And we'll do a render. And that looks very bright. Let's break this connection and so that the ground plane is gray again. And do another render. What you can see is this looks very blown out. So one thing we can do is try to maybe darken up this emissive substance 1. Now there's a couple ways you can do it. You can either go in here and just drag around this luminosity slider, which will definitely change it. However, if you want to use these substance materials with mental ray, it's not such a good idea, and that's because the substance materials by themselves alone are not compatible with mental ray unless you use scripts that come with the plugin that I couldn't seem to get working. I'm not sure if they're compatible with my 2013, which is what I'm using. If you use my 2012, I believe they are. But if you want to use it with mental ray, the solution I thought of is batch baking out the textures for each frame. I'm currently working on a script to do that. If I complete it, I will release it and publish it. So you need to batch bake the textures and then plug in an image sequence as a file texture or something to use with mental ray, which would definitely be very cool to use because of mental ray's much better realistic lighting system. So Anyway, that said, instead of changing the luminosity value here, we're going to actually use another utility node. We're going to use the remap HSV node. And HSV, for those of you that don't know, H is hue, S is saturation, and V is value. Value is basically the same thing as luminosity, and these two are pretty much obvious. And what you notice is it's very similar to the node we were just working with, the remap color. Because basically, you could represent additive color, which is what your monitor or TV produces. Anything that emits light produces additive color, whereas things that are printed are subtractive color. So, additive color can be either represented as red, green, and blue, or hue, saturation, and value. So, these do similar things, but they transform the color differently. So anyway, let's connect the out color of emissive substance to the in color of remap HSV. And then what we want to do is we want to play around with the value of the remap HSV node. And that's what we want to plug in for incandescence. So let's break this connection here that connects to incandescence and connect the out color of remap HSV to the incandescence of Lambert 2. So just click out color and you click incandescence and you're done. So now what we need to start doing is playing around with these values. And to do that, I'm going to use a very handy piece, or a very handy tool in Maya, which is the IPR renderer, which updates renders on the fly, which is really handy. Cool. So basically you just select the region that you want to be updated. As you make changes, it'll make this little cool test render there. And as we change things, the render will update. So let's slide this guy down. As you can see, it got a little duller, which is precisely what we wanted to happen. So now what happens if we take saturation and play with that too? Well, obviously we don't want it to get red, so clearly that's not what we want to do. So what if we bring this side down? You'll notice that it becomes more white. So let's bring that down a tad because I think it was just slightly too blue. And now let's play around with this value slider. And what you can see is that the not so bright parts of the shield are getting dimmer. Now they don't totally disappear, so maybe there's something else we can play with to do that. And now I'm going to go back to the substance node to play with some of its settings. The two settings that are super important here to really work out before you batch bake them or finalize this are the glow intensity and glow size. So watch what they do. Let's change glow intensity first. Let's move it all the way down to 0 and see what happens. What you can see is that the glow seems to get dimmer and the electric lines seem to get sharper. Let's do the same thing for glow size. Same effect happens. So now what happens if we bring this one back up maybe? We get much brighter and much more substantial lines being output. So anyway, that's one thing you can do to make your shield appear more contrasting. The other thing you can do is obviously play with the contrast slider, which will also make it look more contrasted. So let's use something like this. Now Maya does have a contrast node that you could also pump it into, but I mean, I figured 2 nodes was enough to play with. So if you wanted to edit these values later on after you've batch baked it, Maya does indeed have a contrast node you can use. Whoops, there it is. It works not exactly similar to the other nodes we've been working with, but basically you just input, a texture to the value, and it's out, and you change however you want the contrast for each channel, and it outputs the new texture. I'm going to delete that because we're not going to use it though. It's a little different than these guys, so I decided not to. Anyway, let's take this and drag it out. The one thing I want to show you guys are these cool input and output ranges. The input and output ranges basically shrink or expand the ranges at which the input is accepted and the output is accepted. So if we shrank the output range, by bringing down the output max, that literally will take down the maximum value that the node could output. So if we take the output max down to 0.9, what happens? It gets darker. To really show that, let's bring it down to 0.5 to show a dramatic change. It definitely gets much darker. And we don't want to do that, so let's bring that up to about 0.92 maybe. And this is how we really start to get certain regions of the shield being really, really clear compared to other parts. And the other thing we can do is play around with the input and output max. What this basically does is say, well, only transform the regions of the color channel between min and max for input. So if we bring this up, you'll notice it also gets much clearer because all those values that are less than input min are now just being set to whatever the output min is, which is 0. So you can play with that, but be careful because now obviously there's nothing there. So maybe let's make that 0.02. I think that looks pretty good. And if you change the input max, what you'll notice is that everything also gets brighter, basically. And that's basically the same principle as input min. But let's leave that at 1. And I want to tone this down just a bit. And then let's also just do a little bit with this. That's a little too blue for me. Okay, cool. So now one thing we can also do is first scale up our texture. I was using it in lower resolution just so it would be faster, but let's change it to 2048. Now it'll redraw the texture, but that means it'll also render at a much higher resolution so we get much finer detail. I'm just going to do a new render in total here. And you can already see, let me zoom in some, how much higher the detail quality is. Now the last thing you want to do is basically just add glow like I showed in the example video. And that's what gives it that flickering effect, like it looks like it's giving off light. And to do that, there's actually a fairly easy way. The simplest way, I would say, is to just connect some of the attributes from remap HSV to the glow intensity of the Lambert. And the one I chose was outcolored blue because that's the most prominent one. So you can take that and let's connect it to glow intensity. Glow intensity says basically that this text will glow this much. So let's do another render and see what happens. Wow, that is definitely very bright. So the solution I came up with was to add a specific attribute that controls that specifically. So I just added it to the polysphere because that's easy to access and see. Let's go to Edit, Add Attribute, and add an attribute that I'm going to just call Glow Factor, which is short for glow factor. Make sure it's a float, and obviously that it's a scalar. And you should make it keyable if you want to change how intensely it's glowing. Okay, so hit OK there. And let's set this to a default of 1. Alright. And now what we need to do is we need to open up the expression editor, which is in Window, Animation Editors, Expression Editor. And what we want to do is we want to take the glow intensity of Lambert 1, set it equal to something. And the expression we want to basically create is setting this equal to a product of two things. First of all, the blue out color of the remap HSV node, and then make that the product of, or set it equal to the product of the remap HSV node blue and our glow factor attribute. So the first thing we need to do is break this connection here between out colored blue and glow intensity, otherwise we won't be able to define an expression. So paste that once again. Lambert2.glow intensity equals psphere1.glowFac. Remember, that's the attribute we created, times, and basically we just need to take the name of this node, which is remap hsv1.outColor. These things are case sensitive, I believe, so you might want to be careful. OutColor, and we need to say B to specify the blue channel. And put a semicolon at the end just for good practice. Create. And now we've created an expression to control the glow intensity with our own parameters. So as you can see, the glow is still just as bright, so what gives? Well, one thing we need to change is this factor GlowFac. If we change this to 0.2, watch what happens. Let's save this render and re-render. The glow is definitely a lot dimmer now. So, basically, that's it. By changing this glow factor thing here, you can play around with how bright or how dim you want your glow to be. So let's make it 0.4, see what happens. So I think that's a fairly good amount of glow. Yeah, you have a cool little glow on your shield there. Let's use it 1-to-1. You can see that you'll definitely get areas where the glow is brighter and areas where it's not so bright, which will give you that cool flashing effect. Now, obviously, if you want to change various parameters, you can. The main advantage to using this method is that you've created a procedural texture that gives you the ability to change various attributes of the shader network and get effects. Now, this does increase render time, so I'd be careful if I were you. Don't go too crazy if render time is going to be, a problem. So keep that in mind, because by putting in these nodes here, you have added more computations that Maya has to do per render. So be careful. There are more efficient ways to do it. You can batch process your textures in Photoshop if you want, after finding what values work for you using these nodes, or if you choose to, you can use these. But yeah, remember that you can always go back and change these values to do whatever you want, and then you could bake out this texture if you have a batch baking script, and then use it with Mental Ray or any other renderer if it doesn't support this, or if you just want it to be more efficient. The problem with using these materials is it has to redraw the texture every frame because it updates it if it's animated. If it's not animated, obviously that's not the case, but yeah, you just have to be careful with that. But yeah, that's about it, guys. So you can play it, and it's going to go kind of slow because, like I said, it's drawing the frames at 2048 every frame, so it's not going to be the fastest thing. But yeah, that's how I produced my video. So hopefully you can produce some cool results yourself. If you want to, you can even use the other materials here, the other stylized materials, and make an effect of your own. So if you do, upload it to YouTube and let me see it. I would definitely like to see what you guys have made. Thanks, and I hope you enjoyed it. I'll see you guys in the next tutorial.